Sharon Jones, and today we're going to dig in to look at the connections between math and computer science. This is going to be so exciting, and you're going to see how what you're doing every day in the classroom already connects to computer science. First, let's talk about that at the root of computer science is mathematics. Math matters for computer science because it teaches students how to use abstract language, work with algorithms, self-analyze, think through how to solve a problem. Think about learning multiplication, division, fractions, decimals. Oh my, so many things that you work through in math that have its own language and own thought process. That at the core is what drives computer science. We are using binary code in computer science, which is zeros and ones, to drive the work. And understanding at the core how to use math to help that happen is so important. So let's take a look at a couple of vocabulary words that cross over all the time between math and computer science. The first one is algorithm, which you as a mathematician and math teacher use on a regular basis. Those are the steps you take to solve a problem. We teach students how to use algorithms when they're doing multiplication, division, solving for fractions, understanding a pre-calculus or calculus formula, and those pieces are fundamental in computer science because we use algorithms to create instructions that allow us to automate information. So the computer is able to do processes and content faster. A variable is a symbol which functions as a placeholder. In mathematics, we use that for x to solve for y, or use x plus y equals z. Wherever we're using variables, we use it to solve problems. And in computer science, we use variables in the same fashion. Think about when you log into your computer or log into your email. You have a username and password. That is a variable because it's different. It's a placeholder because your login and password is different than your next door neighbor's. And that's how we use variables in computer science. It also allows us to create an algorithm that can be used for multiple different ways. We just plug in the variables. Same thing happens in math when you're learning how to multiply. So at the core of all of this, though, is the concept of computational thinking, where you decompose, pattern recognize, abstract, and create an algorithm. We do this naturally as humans all the time when we're thinking about if I get up in the morning and I get up early enough, I can get coffee. We're already decomposing in our brain the process we need to do to make sure we get up early. Usually that means setting an alarm. And then we take out what we don't need. And we create an algorithm so when we go to bed at night, we're ready to get up in the morning. That is something we do naturally. And in mathematics, we're also given word problems, or we have to think about how to multiply or divide or solve for a fraction. Those are stuck in my head right now. So let's look at a quick activity that you can do that uses algorithms, but also talks about fractions. I don't know about you, but learning fractions can be hard for students. Also, you can think about fractions in terms of proportion. So let's look at this. This is called Algorithmic Doodle art. And what we do is we give students a set of instructions. Now you could do this one of two ways. You could do it verbally, where you verbally tell them the instructions that you want them to do and they must listen and process, or you can have them write it out. This is using algorithms to draw simple pictures of nature. You could choose any piece you want it to do. What they're going to do is you're going to give them the algorithm, and what we know is that algorithms are what we call recursive, and that is they describe one step and then tell you how to do the next one in the same way. That recursion is part of what we do in computer science so that our computers will do the same thing over and over again. So let's look at this example. What we want to do is you start telling students to draw a single straight line, and then you give them the option to draw 3 shorter lines at an angle in the top 2/3 of the line on the left side. So what that means is they must understand their left and their right. And we want them to figure out how to move to that left side and do the top 2/3. So before you want to do this, you may want to introduce what is 1/4, a half. Let me do that. Make a whole. 1/4, a half, 3/4, make a whole. And then you could talk about thirds. You have them draw and see what they come up with. This is an example of what it could look like. The other piece that I wanted to add in here too is that when you're creating this, you can ask them to repeat. That's the recursive piece, and it also introduces something called a loop, where we're repeating something more than one time. So let's take a look at this again. You start by drawing a single straight line. Ask them to go to the top 2/3 on the left-hand side of their image and draw another straight line and see what they come up with. This is following an algorithm to come up with a design. So let's think back. We used a couple of different things here. We used the word algorithm, and we also used a variable, because remember, in the algorithm, you could change it from 2/3 to 1/4 or 1/2. You could use any type of fraction or decimal that suits you. Again, this has been Dr. Sharon Jones, and I am discussing how to integrate math with content and computer science. Thanks for joining, and I look forward to seeing you again next time.